In this tutorial, we will discuss about substitution reaction of the type SNI. The label SNI stands for substitution nucleophilic internal. The reaction between alcohols and thionyl chloride has been studied extensively in this regard. A thoroughly studied example is alpha-phenyl ethanol. It was found that the product chloride is formed with complete retention of configuration of the starting alcohol. The reaction proceeds with the formation of a chlorosulfide ester which collapses with elimination of sulfur dioxide, that is SO2. The ester can be isolated. The reaction is common with aryl methanol but not with other alcohols. The chlorosulfide ester could form the product by SN2 with inversion or SN1 with racemization. But in the present case, there occurs total retention of configuration. So, a new pathway is likely to operate. Here we will discuss about the reaction mechanism. On the basis of experimental facts, the mechanism of SNI is formatted as follows. In step 1, the first step is formation of chlorosulfide ester, that is the intermediate. In the second step, dissociation of chlorosulfide ester to form an ion pair. Note, it is not dissociated ions. In the third step, because of the geometry of the ion pair, the chlorine atom is forced to attach the carbonium ion from the same side as original carbon-oxygen bond of the alcohol, and this is referred as internal attack. The SNI mechanism is occurring rarely, and another example is the reaction of 2-octanol with phosgene that proceeds with retention of configuration. It is interesting to note that in S1-phenyl ethanol and thionyl chloride react in the presence of tertiary amine such as pyridine. The product R1-phenyl ethanyl chloride is obtained, that is, inversion of configuration occurs. The pyridine reacts with hydrochloric acid produced in the first step to form pyridinium hydrochloride, and the chloride ions, being an effective nucleophile, attacks the alkyl chlorosulfide from backside via a normal SN2 reaction, as it is shown here. Thus we can say, in the presence of pyridine, reaction follow SN2 mechanism, while without pyridine, reaction follows SNI mechanism. Another example of SNI is that of plus malic acid, as it is shown here, and the reaction proceeds with retention of configuration via SNI pathway. In SNI reaction, both the reactants are the crucial component and are playing crucial role in completion of reaction. Thus, rate will be directly proportional to the reactant and catalyst. Therefore, we can say the reaction follows a second order rate equation. For example, rate equation in case of chlorination using thionyl chloride comes to following form: rate is equal to K, which is the rate constant, multiplied the concentration of alcohol and concentration of thionyl chloride. Note that the rate of decomposition of the intermediate chlorosulfide ester increases with the increase in polarity of solvent.